Now, we can factor polynomials by other means. This example will be factoring polynomials by grouping. We'll typically see this technique used when we have 4 terms in the polynomial. Now, we won't be solving for the variable. We won't come up with a final numeric answer, but we will, hopefully, create a different polynomial that is simpler by regrouping and factoring the regrouped terms. So here we have 12p cubed minus 21p squared plus 28p minus 49. Now, what we're going to do is we're going to group these terms in clumps of 2. So if we take the first 2 terms and we box them in, so visually we can concentrate on these 2 terms, and then we'll take the back 2 terms and we'll box those in as well. Now, from the front 2 terms, we'll find the greatest common factor, and we've looked at that in another video. And we see that the greatest common factor for the numbers 12 and 21 is 3, and the greatest common factor for the variable piece is p squared. So if we divide out 3p squared from just these 2 terms, well, 12 divided by 3 will give us 4, and p cubed divided by p squared will leave us with p, and we have the minus. 21 divided by 3 will give us 7, and of course p squared divided by p squared will give us 1, and 7 times 1 is 1. Now, on the back 2 terms, we notice there's no variables in both terms, so we won't be factoring out one of the a variable, but we do look at 28 and 49. We find the greatest common factor between those 2 numbers, and we see that that is 7. So we will factor out a 7, and 28, if we divide out a 7, will give us 4. And as we see, we're not dividing out any variables, so we'll maintain the letter p minus 49, again divided by 7, will give us 7. And now we notice, if we think of this grouping as the first term and this grouping as the second term, we notice something is common between the first term and the second term, and that is the term in parentheses, the piece in parentheses, 4p minus 7. So once again, our core idea in factoring is we can divide out a piece if it is present in every term. And we see in this term we have 4p minus 7, and in this term we have 4p minus 7. So let's divide out 4p minus 7, and from this front term, if we divide out 4p minus 7, all we have left is 3p squared. And from this back term, if we divide out 4p minus 7, all we have left is plus 7. And so we see we can take a fairly complicated looking polynomial and we can simplify it down to something that maybe looks a little more manageable. And this is our final answer. Now, that's example 1. let's take a quick look at some interesting tweaks that we can make to this. Here's example 2. Now the principle remains the same. The idea is the same. But take a look at this piece. If we have 12x cubed plus 2x squared minus 30x minus 5. Well, let's break this down. Let's take the front 2. Let's take the back 2. Notice that we are including the sign in the front term of the back 2. Well, let's see. 12x cubed plus 2x squared. The greatest common factor is going to be 2x squared, so let's factor that out. 2x squared. And what do we get? 12 divided by 2 is 6. X cubed divided by x squared is x plus 2x squared. 2 divided by 2 is a 1. And x squared divided by x squared is a 1. So notice we have a 1 there. Remember, we'll always have this second term. Just because they cancel and we don't see the 2x squared anymore doesn't mean it becomes 0. No, remember, we are dividing out a 2x squared. So 2x squared divided by 2x squared gives us a 1 here. Want to be careful about that and not think that that would be a 0. And now, for this second group, we'll put in a plus before we start finding our greatest common factor. And if you notice, let's see, we don't have variables in both, so we're not factoring out an x. And the greatest common factor is a 5. So let's see if we factor out a 5. Negative 30 divided by 5 will be negative 6x. And negative 5 divided by positive 5 will be negative 1. And now do you notice when we look at our two terms, we look at our two terms, we go looking for something common in both of them, we say, boy, this doesn't exactly match, does it? This term in parentheses is very close. We have 6x plus 1. And over here we have a 6x and we have a 1. But you notice they're both negatives. You say, well, I can't factor that out. That's not a match. But let's take a look at our process. Do you notice from these two terms, we factored out a plus 5. Now, we want to create in these parentheses 6x, a positive 6x, and a positive 1, so we can factor this out. When you have the exact same terms, but their signs have been reversed, positive, positive, and over here we have negative, negative. When you have that situation, that's kind of a tip-off. Instead of factoring out a positive 5, do you notice we could factor out a negative 5? Now let's look and see what that would look like. Our front term will stay the same. And now, put in the plus, and now instead of factoring out a positive 5, sort of going back to step 2 and making some changes, instead of factoring out a positive 5, let's factor out a negative 5 from these back two terms. Now a negative 30 divided out a negative 5 will give us a positive 6. And of course the x is coming down. A negative 5 dividing out a negative 5 will give us a positive 1. Now we like this. Now we've got a match between the first term and the second term. Let's circle that. Now we've got what we were looking for. So if we factor out a 6x plus 1, From our first term, we have 2x squared. And from our second term, and here's where we have to be aware, we have a plus negative 5. Well, a positive times a negative gives us a negative, of course, so this simply becomes negative 5. And there we have it. Simplified form. We had to be a little aware when we saw this mismatch. We had to say, oh, I think I need to change what I factor out. We redid step 2, and we factored out a negative 5 because we have the exact same terms. It's just that their signs, positive, positive, were flipped to negative, negative, and we had to account for that. Okay, now there is one more small tweak that we can see to this. Suppose, and this will be, of course, this will be example 3. Take a look at this one. We have 8x cubed minus 64x squared plus x minus 8. Well, we're fairly comfortable with this process now, so we'll take a look at the front two terms. There we go. And we'll take a look at the back two terms. Notice that we're boxing in the sign of the front term there. Well, let's see, front two terms, greatest common factor is going to be an 8 for the numbers, and for the variables, it'll be x squared. So what do we have from that? Well, 8 divided by 8 is 1. X cubed divided by x squared is x. And the minus. 64 divided by 8 is 8. And x squared divided by x squared is 1. So we'll stay there. Plus. And now when we look at our back term, we notice, well, there's no numbers common to both, except for 1, of course, and that really doesn't help us with the greatest common factor. There's no numbers to factor out. There's no common numbers. And there's no variables in both. You say, well, I guess we'll just copy down x minus 8. We certainly can't factor anything out. Now, here's a subtle piece. If we box in, if we look at this term, and we look at this term, you notice both of these have x minus 8. Got them both. Well, let's see what happens if we factor out x minus 8. Well, the first term's pretty easy. If we factor out x minus 8, well, all we have left is 8x squared. And then we have the plus. Now, if we factor out x minus 8 from this back term, essentially what we're doing, I'm going to put this a little down below so you can see it. We're actually taking x minus 8 and we're dividing out x minus 8. Well, what is x minus 8 divided by x minus 8? It's just 1. It doesn't go to 0, remember. If we divide out an x minus 8, we're using division. So x minus 8, divide out an x minus 8, and x minus 8 divided by itself would give us 1. And you notice, if we multiplied this out, we would get back to our second line. So there's a little piece of subtlety there that you have to be on the lookout for.